Welcome back. In this class, we're going to talk about hydrogen as a fuel. So it's really important here that you can tell me how hydrogen is produced industrially, including the balanced equations, but also any dangers associated with hydrogen as a potential fuel source. So on screen, we have what do you actually need to be able to do? Now, while this is quite a short topic, it's only covered in one page in your notes. It does come up a lot on the exam, and it is a lovely, beautiful short question when it does. It's usually stuck on the end of an octane number question, so in question 6, but it could come up in question 4 as well, the short questions. So what do you need to know? Number 1, you need to be able to give me 2 uses for hydrogen gas. So what do we possibly use it for? And you get 3 marks for each use that you can name. Number 2, you need to be able to describe 2 methods of producing hydrogen gas industrially. And that will include the balanced equations, particularly for the methane one. And we'll see that in a second. And number 3, you should be able to describe any danger associated with hydrogen as a fuel. And that will get you 3 marks. Now, part number 2, for the methods of producing hydrogen gas industrially. On average, that tends to be 6 marks on the exam. So it will either say, write a balanced equation for steam reformation of natural gas, that will get you 6, or it will ask you to name 2 possible methods of producing hydrogen gas industrially, and that will also get you 6 marks. But they tend not to come up together, so it's either like an either or situation. Right, so up first, we have our uses for hydrogen gas. So hydrogen is H2. It is a lovely gas and it's particularly useful as a fuel. Now, this chapter in your notes comes up under the fuels topic. So we're going to go after it as an excellent fuel, and it's brilliant as a fuel. Now, from all that we've studied about fuel so far, what would make something a good fuel? If it has a high octane number, it would be considered a good fuel. So a high octane number, that's why it's a good fuel. Or you could say it has a high kilogram calorific value. Now, if you're ever given a fuel and you're like, I don't know if this is a good fuel or not. If you're told it is a good fuel, the reason why it's a good fuel is it has a high octane number. So even if it's something that you haven't seen before, and if it asks you, why is this a good fuel? What's the benefit of using this as a fuel? It has a high octane number and you get 3 marks. But hydrogen as a fuel has another advantage. It burns cleanly. So when you have hydrogen and you combust it, hydrogen combusts in oxygen, but the only product of that combustion is water, because hydrogen combines with oxygen to give me H2O, and you have a half in front of the oxygen. So it burns cleanly. You're not producing carbon dioxide, therefore you are not contributing to global warming and the enhanced greenhouse effect. Okay, now the next one, it can be used in the production of ammonia. Now, this is going to be a case study that we will see in the option topic towards the end of the year. We'll discuss how do you form ammonia. But that's formed from nitrogen, from the air, reacting with hydrogen, from usually methane or natural gas, and we form NH3. To balance, we put a 2 and a 3. Technically, it's an equilibrium reaction, but I'm not going to get hung up on that just yet. Now, so the production of ammonia. Ammonia is a very important compound because it's used to manufacture fertilizer. So it's very, very, very important to keep the current food levels on the earth where they are. Now, another one, hydrogen is used to manufacture margarine, but they would be the 2 examples that I would use because particularly for a fuel, that if hydrogen comes up in the exam, the examiner is going to be going after it as a possible fuel source. Now, the danger of hydrogen and why it's not widely used at the minute as a fuel source, because it would be very easy to obtain, but hydrogen is massively explosive. So that's why it's not widely used yet. There are some hydrogen fuel cells and they are rolling them out a little bit more now. However, it's massively explosive, so there's a safety concern with that. Okay, so for the industrial production of hydrogen gas, so if we want to use hydrogen as a fuel or to make ammonia, we have to have developed ways to obtain hydrogen in a way that's cost efficient or cost effective and in a way that could give us large quantities of hydrogen gas. There's two methods given in my notes, but technically there are three possible answers here. So let's have a look. The first one is the most important one, so learn this one. The steam reformation of natural gas. And this is where we get hydrogen from natural gas, which is methane. Okay, now steam reformation. So if we're writing a balanced equation for this, steam is H2O and natural gas, that is CH4. So if I wanted to write the balanced equation for that, you start with one of those two. I'm going to start with CH4. It doesn't matter which one you put first. When they react together, you form two products, carbon monoxide and hydrogen gas. Now to balance your equation, let's split it into the left and the right. Make a list of my elements. I have carbon, hydrogen and oxygen. On the left side, I have one carbon. On the right, I have one. It's balanced. On the left, you have 6 hydrogens, but only 2 on the right. So we're going to have to balance that. 1 oxygen on the left, 1 oxygen on the right. So to balance this, I need to put a 3 in front of the H2. That will multiply by 2 to give me 6. You have the same number of atoms of each element on each side, so that is my balanced equation for the steam reformation of natural gas. And yes, you must be able to write that. The bit where people get stuck here is the carbon monoxide. It's carbon monoxide, not dioxide. Right, so that. A downside to that experiment, or for using that method, is you form carbon monoxide, and that is very toxic. Later on, when we do the option topic, this reaction is actually carried out in the factory where ammonia is made. So you actually generate the hydrogen in the same place that you will then be using it to make ammonia. And what they do with the carbon monoxide to get rid of it, it's not relevant for the hydrogen question, but you will see it later on. They take carbon monoxide and they react it with more steam. And by doing that, they form carbon dioxide and even more hydrogen gas. So you're converting carbon monoxide, which is super toxic, into carbon dioxide, which is not toxic. And then you can use carbon dioxide. It's used in fire extinguishers, fizzy drinks, etc. So you can sell it and make money. Or it's actually used in another process later on to make urea in the same factory. But another good side of doing, or good reason of doing that, is you make even more hydrogen, which can then be used with this hydrogen to make NH3 further on in the factory. Okay, so now we get rid of that. So all you need to be able to do from this is actually write that balanced equation for the steam reformation of natural gas and name it. Steam reformation of natural gas. Now the second one is using electrolysis of water. And you need to specify that it's electrolysis of water. Electrolysis is where you pass an electric current through a solution and it causes the compounds in the solution to split up into their elements. So we're going to do that in relation to water. Now this works best if you have acidified the water first, usually with sulfuric acid. So when you pass electric current through H2O, that causes water to split up into its elements. The elements that make up water are hydrogen and oxygen. So you form H2. Now be careful here. Oxygen does not exist on its own as individual atoms. It's always a molecule as O2. Now to balance, I'm going to put a half in front of the O2, but you can multiply across by 2 and have 2 of everything else and only 1 oxygen. It doesn't matter. Okay, so that's my balanced equation for the electrolysis of water. Now to do this, you would use platinum electrodes. and it would have to be acidified water. Now, there is a third one that isn't mentioned in your notes, but now that we've come to the end of the fuels topic, I'm hoping that you're able to remember back to the oil refining processes that are carried out in order to affect the octane number. One of the processes that we discovered actually gets rid of hydrogen from the hydrocarbon, and it was called dehydrocyclization. Oops. So dehydrocyclization of hydrocarbons. Now, you don't have to be able to write a balanced equation for this, but it is a third method of producing hydrogen industrially. Because if you're in an oil refinery and you are taking a hydrocarbon and you want to increase the octane number of it by undergoing dehydrocyclization, a byproduct of that reaction is you produce hydrogen gas. So you can then use that hydrogen gas and sell it to someone that needs hydrogen for industry. Okay? So there are my three methods. There's really only two, and if you can write those two balanced equations, you're good. Right, in summary. So hydrogen is explosive, but it is a brilliant fuel. So its uses, it can be used as a fuel. It can be used in the production of ammonia. And it can also be used in the production of margarine. Now, a reason why it's a fantastic fuel, it has a high octane number and it burns cleanly because water is the only product of the combustion reaction. So water is the only product. Okay. Now, in order to produce hydrogen industrially, so the production, you should be able to give me two ways of producing. Number one is the steam reformation of natural gas, which is where you take methane, react it with steam, and we form carbon monoxide plus hydrogen, and we balance by putting a 3 in front of the hydrogen. The second is the electrolysis of water, where you pass electric current through acidified water and you split the water into hydrogen and oxygen molecules like that. Now, and that's pretty much it. That's all that the examiner is really going to ask you in relation to hydrogen as a particular fuel. In your notes, I've also given you a worked example from 2022, question 6C, part 1. Suggest a reason why elemental hydrogen does not occur in nature as a fuel source. So why do you not have elemental H2 banging around the atmosphere or stored under the surface of the earth? It's reactive. It's explosive. So if you happen to have hydrogen or pockets of hydrogen somewhere, as soon as air gets at it, it's going to react with oxygen in the air and you're going to form water. So it is massively reactive and it is explosive. So it's going to have reacted with something else before humans can come along and dig it up and use it as a fuel source. So that's why. Right, that's it for hydrogen as a fuel. So now we are finished the fuels topic. So you have all of the information in order to answer question 6 apart from the thermochemistry section.